Coming up on This Week in Space, we're looking at 50 years since the Apollo-Soyuz historic docking. I check out the biggest piece of Mars on Earth, and Rob Manning, JPL engineer extraordinaire, chief engineer emeritus, is going to walk us through Mariner 4, 60 years after our first close-up of Mars. Check it out.
Podcasts you love.
From people you trust.
This is Twit.
This is This Week in Space, episode number 169, recorded on July 18th, 2025, the day Mars died. Hello, and welcome to another episode of This Week in Space, the Day the Mars Died edition. I'm Rod Pyle, editor-in-chief at Astor Magazine, and I'm joined by my fellow Martian, Tariq Malik, also editor-in-chief at the much larger space.com. How are you doing, friend?
Hello, happy Mars Day. Well, I guess it's not Mars Day, it's just Friday.
Well, actually, it is, because we're coming up in 2 days. We have Apollo 11 Day, which is landing on the moon on July 20th. But that was also the date that the Viking 1 lander set down, which is our first successful landing on Mars. We often forget about Viking, but I don't, because I'm an old man and I was there. In a few minutes, we'll be joined by another guy my age, Rob Manning, who's one of our favorite returning guests. Former chief engineer, now chief engineer emeritus at the Jet Propulsion Laboratory in Pasadena. And we're going to talk about the 60th anniversary of America's first successful spacecraft to Mars, Mariner 4, in 1965. However, before then, please don't forget to do us a solid. Make sure to like, subscribe, and do all the other podcast things that make us feel loved, because we love you and we need your support, and so forth. Now, we have an encore joke from Paul Woolley. Encore. I thought you were going to scream Paul, isn't it?
Paul!
There we go.
Paul Woolley!
Hey, Tariq.
Yes, Rod.
Why did the Mars rover apply for therapy?
Why? Why did they do that?
Because it had abandonment issues.
Oh, no.
That was a few weeks ago I used that. Okay.
I don't remember.
Because that was a recycled joke. A fresh one from Nate Tanner.
Nate.
Hey, Tariq.
Yes, Rod.
How did Pluto react when Neil deGrasse Tyson said it wasn't a planet anymore?
Ooh, I don't know. Was it sad?
It said, I think Neil deGrasse Tyson is fat.
What? What?
That
Nate,
wasn't mine.
That's not nice.
Yeah, a little bit of a reach there. Now, I've heard that some people want to abandon...
He looks good now, by the way. He's good. I don't know. He's in shape.
Thank you. I've heard that some people want to abandon us on Mars. It was joke time of the show, but you can help. Send us your best, worst, or most of different space jokes to twist@twit.tv.
He's also got the best space vests, too. It's pretty cool.
But Gene Kranz, you know.
Well, there's that. Yep. All right.
Yeah.
Stand corrected. Stand.
Oh, my God. How do these guys get these GIFs up so quick? He's got Tyson up already. All right. Headlines.
Headline
news. There we go.
Headline news.
Headline news. I got that science.
Never did we get so much use out of something it took me so little time to make. Hey, Tariq.
Yeah, let's zoom through these, because we've got a show ahead. So
50 years ago, we
Yeah.
had the Apollo-Soyuz flight, or as they called it in Russia, the Soyuz Apollo flight.
That's right.
Which was the final use of Apollo hardware. Now, for those of us, there's I'm noticing in the press and social media sites a fair amount of misty-eyed looking back at, it was the final flight, and that was so cool and all that. At the time, I think the public, it was a little bit of a yawner. You know, we had been on these incredible missions of exploration to the moon. We had 3 crews up at Skylab, which was rescued from near disaster because of a launch that broke some things. And then came Apollo-Soyuz, which was cool primarily, at least from the public view, because it was détente in space. It was the Americans and the Soviet Union docking 2 spacecraft, shaking hands, sharing some borscht and some jokes, and then going their separate ways. But it was kind of it felt, just personally, it felt a little bit like kind of a sad ending to this amazing program. But it's been, what?
Well,
60th, 50th anniversary, right?
50 years later, we've got an International Space Station where we flew one of the most international missions I've ever seen just like a week ago. You know, you've got Russians and Americans in space overseeing a station that also has, I think it had, we had India's space agency's first astronaut, Poland Bulgaria, Hungary, and then there's more on all up there. So I think that the legacy is far-reaching. Given where we are now, I know there's a lot of stuff with Russia and Ukraine and stuff that's throwing a lot of mixed, a lot of waves in that international cooperation. Hopefully, we'll get through all of that, and that conflict will end, and then they can resume. Or maybe there's another partner that's going to rise up and be even more cooperative and more. What's the word? What's it when you're good? Beneficent? Beneficent? Yeah, more good.
Munificent. Well, it would be great if we could work with China, because I think, honestly, they wouldn't say so, but I think China would turn off their relationship with Russia in terms of space in a hot minute if we could find a way to work together cooperatively. Because really, there isn't a lot left going on in Russia. They've got some old hardware. They've got some capability, but they've had huge brain drain through retirement and other things. And their budget at this point is tiny, and their spacecraft break. So,
yeah. You mentioned Skylab, by the way, and we just passed the 40th anniversary of the Skylab fall from space into Australia. So,
all right,
let's hope we don't do that with the ISS.
Well, speaking of falling from space, Starliner got a brief moment back in the news.
That's right.
I guess we finally got an announcement after many months of silence. This is Boeing's.
It's been since March. Can you believe it that they said anything like publicly at all?
Competition for SpaceX to deliver astronauts to the space station. And the headline I picked was Starliner in or out of the doghouse, nyuk, nyuk, nyuk. Where do we stand with this darn thing?
Well, that was the question. Back in March, NASA and Boeing put out a statement that said that they were looking firmly into early 2026, no longer looking at the end of 2025 for the Starliner 1 mission, the next Starliner mission. And they were trying to decide if they get all of the testing done that was slated for this summer, and then if they would put people on it or not. We actually reached out to them like a week or two ago, Boeing and NASA, and they're like, hey, no, like what we said in March, that's what we said, and so
that's the latest news.
That's what they told our writer Josh Dinner, who, by the way, wrote this great story, because during the Crew 11 upfronts for the Crew 11 mission, which is launching by SpaceX at the end of this month, as we're recording it, July 31st is the launch date there. They did give an update on their plans for Boeing, and they did confirm that not only is Starliner launching in 2026, that next launch will also not have astronauts on board. So they're stepping back and they're doing another like cargo kind of / test flight for this version for whatever fixtures that they're going to be making. And so it's a pretty definitive like a stake in the ground now that is when the next mission is going to do. Now the testing is going to be set for the summer to test like the doghouse stuff that they were tracking for the thruster issues, to see if they can manage the temperatures there so that they don't pose a problem again and have like a lot of the glitches that they saw on this last
temperature on the thrusters.
Exactly.
Yeah. And I guess what I read anyway was they're redesigning the material for the seals on the valves, since valves seem to be a problem for them, even though they've been building them for space for 60 years.
Yeah,
it'll be interesting to see what happens. There was a good story on Ars Technica, not by Eric Berger, by another writer, about we're counting down to the end of the space station. So
is it
really,
still worth it? Yeah.
How many flights can they get done in time? Yeah. Why don't you pick the third story? Whatever you like the best.
Yeah, well, I would just point out, I mean, there's a lot of great stuff. There will be the Apollo 11 anniversary on Sunday, July 20th of this year. There's going to be a protest scheduled at NASA headquarters.
By NASA workers.
By NASA workers, contract and employees who are protesting both the mass layoffs as well as the budget cuts there. It'll be interesting to see what that turnout is like and if it has any impact into the ongoing budget discussions. But I did kind of want to end on a high note, and I would just add that I did get the chance to see the biggest piece of Mars on Earth this week, Rod, because it was here in New York City. And I got a little video.
Now, is this the new meteorite?
Yeah, it's not a new meteorite. It's newly found. They found it in 2023.
Right, newly on sale.
Yeah, there's a bit of a video in the background from my visit earlier this week at Sotheby's. Is it Sotheby's or Sotheby's?
Doesn't matter.
Okay, yeah.
How big is this piece?
It is 50, I think it's like 56 pounds or 54 pounds, something like that.
This is multi-million dollar specimen, right?
So I'm glad you asked. It was actually up front because this is the big suspense building. Here I am walking through their exhibit. All this stuff was like on sale, and there it is. You can see it in real time. It
got its own gallery. Look at that.
It's its own gallery. There's no barrier. I could have just grabbed that thing and ran out of that building, right? I can't carry 50 pounds that much that far.
I'd find a way. Look at that.
Yeah, so this was discovered in 2023 in Niger in the Sahara Desert, and it's the largest chunk of Mars, single chunk of Mars that I guess has been on display and up for auction ever. They're billing it as like the biggest. It did sell for $5.3 million, and that is above their top estimated price of $4 million.
We should have bought it and taken it to NASA headquarters and said, "We've just solved your Mars sample return problem."
Yeah, I know.
Only $10 million.
So it was very exciting to see. I feel like Indiana Jones, that it does belong in a museum, but maybe still.
The one moment of Indiana Jones you'll ever have in your life, my friend.
But maybe, you don't know. I could discover a tomb, right? My life's not over yet.
You've been in my office. That's
a space tomb, hopefully.
Yeah.
But we'll see. Maybe they'll donate it to a museum somewhere, and then we'll all get to enjoy it forever.
All right. Well, we are going to buzz off now to a quick break, and then we'll be back with Rob Manning, Chief Engineer Emeritus from NASA JPL, to talk about the 60th anniversary of Mariner 4 to Mars. Stay with us. And we are back with Rob Manning, Chief Engineer Emeritus, which is a title I can only covet in my dreams, of Pasadena's NASA's Jet Propulsion Laboratory. Hello, Rob. Thanks for joining us today.
Rod, it's great to see you again. It's great to be back here. It's really cool.
Well, and it's always a treat for us because you're the most fun a guy can have talking to an engineer, for sure. So can you just give us, for people that haven't heard you speak before, give us a kind of a rundown of your career at JPL?
Sure. Antiquity. So I started off at JPL, remarkably, as a oops. Can you hear me okay?
Mm-hmm.
Yeah. Okay. I started off as a technician and a draftsman at JPL nearly 45 years ago. And I've worked my way up through the ranks, working first as doing electronic systems. Came out of Caltech as a student, and then learned how to make electronic systems for spacecraft. And for some reason, I've managed to find myself becoming a chief engineer for a Mars Pathfinder mission, a little mission to land. A low-cost mission to land a little rover and do some science and some pictures on the surface of Mars after a 20-year hiatus from after the Viking missions that landed on 2 missions on Mars in the 70s. And then after that, I've been doing a lot of chief engineer work. I was chief engineer for essentially not quite chief engineer, didn't have the title, but for a Spirit and Opportunity rover, as well as chief engineer for Curiosity rover, as well as the Mars Program Office, and then eventually chief engineer for the Jet Propulsion Laboratory for 6 years. So, as a consequence, I know a lot of the Mars stuff, and I've worked on many of the Mars missions. In fact, maybe the majority of them that came out of the United States, and so it's and had involved in Phoenix, InSight, landing to Mars 2020, Perseverance rover, Mars Reconnaissance Orbiter, Odyssey, Mars Global Surveyor, Mars Observer that didn't make it to Mars, and including the ones that didn't work: Mars Polar Lander, Mars Climate Orbiter, the infamous ones that didn't work in 1999. But anyway, so it's been fun. I missed that. I was too young to work on the Mariner series spacecraft. I did work also on Galileo and to Jupiter before it was my first cut at doing electronics, and then. A Cassini mission, Magellan to Venus, Cassini to Saturn, I should say, and many others. So I've been lucky to be in the right spot in the right time and learn about how to make spaceships and how to land them, how to drive them around another planet.
Hey, Tariq, look, we have a modest guest. How nice is that? So actually, by my math, and there's a very good reason I'm not an engineer, but by my back of my hand calculation, you've been involved with NASA's Mars exploration for about half its total time.
Yeah.
That be about right?
Maybe.
But you're right, the majority of the missions, because the success rate really picked up in the 70s. Okay, well, my next question was your history with Mars and every probe since Pathfinder, but you kind of covered that. Before I let Tariq jump in with his burning question, I wonder if you might just have a capsule thought on sort of the legacy of robotics on Mars through JPL. I mean, other countries have tried. The Soviet Union actually started flinging stuff towards Mars many years before the U.S. did, and over and over and over and over again, and has never had a complete success.
Mars 2 had a beep.
It's hard.
Right?
Mars 2, Mars 2 made it. Mars 3, I think
Mars 3.
right? Mars 3, and then Mars, and it lasted a few seconds.
That's why I said complete success, Tariq. But thanks.
But I mean, it's, to be honest with you, having a few seconds says a lot. You have to do a lot of get a lot of things right in order to get something to last even for a little while. So, I give them a score. Not an A plus, but it's up there. I mean, they got to Mars. Anyway, that's such a loaded question, Rod. From the point of view of science, I mean, well, we'll talk about Mariner 4 later, but this has been, you can only humans can go to a place for the first time once, and we've been incredibly, I guess the word is blessed, to have the privilege, funded by, thank you, American taxpayers, to explore and learn and share this with everybody, and share it with families, schools, kids, people from really all over, all walks of life. And it's not just a thing we do for a few handful of secretive scientists. Not at all. It's something that's out there. Our pictures go out there to the world, and what we learn about it, we share. And so it's such a great privilege. And so I've been very lucky to be part of it. I mean, you mentioned, you probably noticed that a lot of organizations are attempting to go to the moon or land there, and sometimes they work, oftentimes they don't. You see, well, JPL's contributions have been relatively successful over the last few years. It's not always been that way, and you do build on it. I think one of the key things that really has made this program amazing, I mean, it's for me, is that NASA has let the same people, effectively the same community of people, learn from their mistakes, make a step, take those lessons and feed them into the next mission and the next mission and the next mission, to eventually the probability of it working goes up, and the complexity goes up and the scope goes up, and of course with complexity and scope goes money, things like that. So they are getting more expensive. Well, not really, actually. They were pretty expensive at the beginning too. They've always been pretty expensive, but over time, this accumulation of knowledge and experience has really paid off. I mean, listen, can you imagine having a chance to do another mission after you've maybe got the last mission off by the skin of your teeth, and all the things you can think, oh, well, I'm not going to do that again. Oh boy, whew, remember that, guys? Yeah, that was pretty scary. Let's not do that. Okay, let's not do that again. Okay, let's do something else. Let's fix it. And so we were able to build on those experiences. Not perfectly. Guess what? Because we're human beings. We make mistakes. So things still go wrong, and things still break. But altogether, what a privilege it's been. And so we've got a chance to build on those capabilities and take them through for decades. And I hope people will say that it paid off from the taxpayer's perspective as well. It's not just, giving Rob Manning this incredible set of experiences that only a 12-year-old would dream of. It's about hopefully taking everyone with us, taking people for a ride. I mean, they talk about we should put flags on Mars. Well, we've been planting flags on Mars, and there are people who go to Mars every day, virtually through their machines and extensions of themselves on Mars. And that's just not true of Mars. It was also true of other planets, other places we've gone. But these extensions of ourselves have really opened up doors to these new worlds and revealed a lot of complexity. And it's really informed a lot about what we know about our own Earth, our own place, our own home. And it's been just, I can't say. I can go on and on. I can give thousands of examples, but I'll stop there.
No, I want to see the Martians. That's what I want my taxpayer money to go. I want the Martians, right? So,
I want to see that fossilized femur up there.
Yeah.
or get it out of the archives. Why were you hiding it, Rob? Are you part of the system? Is that what it is?
Absolutely. Yes. I'm not going to tell you.
Before we get too much into the history, because clearly there's a lot of legacy to build on, I did want to ask, because I usually ask, I think I asked a version of this last time you were on the show as well, about your path to space, because clearly you are a Mars guy, as an engineer, but were you a Mars boy as well? As a kid? Is that something that you thought about on your road to space, or was it something that evolved?
Well, Mars seemed like a long. Excuse me. Mars seemed like a long ways away for me. By the way, if you can hear, if there's some sound that there's some gardening out going on behind me.
We're fine.
There's a when I was growing up in the early '60s, Mars was not. Mars is what you read about in Heinlein's books. Or Ray Bradbury or Arthur C. Clarke or all these great writers, Isaac Asimov. These are the people I read about, and so space was distant. But the thought, the vision we had when I had as a kid is about just getting people off of Earth and maybe being in a space station or maybe walking on the moon. Ooh, that would be really cool for humans to actually go to the moon. So my scope was closer to Earth in my head, but space was definitely a huge thing. And the thought that maybe I might be able to have a role in that was almost impossible to believe, but it was something I imagined as a kid, and I daydreamed about this all the time. I was in space all the time. I grew up in this beautiful island in Puget Sound. And I'd walk through the woods near the beach, and we'd look up the sky, this beautiful blue sky with the clouds, puffy clouds going by. And I, although it was beautiful right there, I was flying. I was in space. I was already out there. I was imagining being above us, flying above the blue sky, and seeing the universe with my own eyes.
Wow.
We have to go to a break, so everybody hold your Mars spacecraft, and we'll be right back. All right, coming back from one of my most lame transitions ever. Rob, you touched on something that has kind of blown my mind for decades now, because I think a lot about my mortality. And, you and I are the people in the room here today that are old enough to remember the classical Mars, the Mars before we understood the ugly truth of the solar system. And I mean, there's beauty and wonder in the solar system. But when I was a young man, when you were a young man, people were still looking at Venus, maybe not the hardcore scientists, but a lot of science writers and dreamers saying, oh, Venus is probably hot and swampy, and it might have dinosaurs and all that kind of thing. And Mars, it's a little colder than Earth, and the air is going to be thin, maybe 1/10 Earth's atmosphere, but we can go there, and maybe you can walk around without a pressure suit and breathe out of an oxygen bottle like Robinson Crusoe on Mars or something. And then this amazing probe kind of came out of, for my awareness, kind of came out of nowhere.
Nowhere, yeah.
I was pretty young, Mariner 4. And flew past Mars, sent back a scant 22.5 very low-res pictures, but everything spun on a dime, and the news was Mars is dead. Mars is the moon.
Oh, I know.
Mars is an arid desert planet. There's nothing there, so get over it. And of course, the scientists are still rocking and rolling because they're like, yeah, look, we got that radio occultation experiment. So we measured the atmosphere and we got these pictures back, and that's fantastic and everything. But the romantics among us are going, you killed my planet.
Yeah, that's true. And they were, and even, there's even people who even after then who didn't give up on the idea there's life on the surface of Mars. By the way, there were just no canals and cities or forests. Maybe something else was there, so it wasn't exactly dead. But what happened was, you're absolutely right. The imagination the imagination is an amazing thing. You can imagine and that's what I was doing as a kid. I was imagining these worlds, these places, and just and it was so fun, so free. I mean, so in some sense, Mariner 4, when it pictured that one image of the crater with craters and craters on it, just like destroyed people's hopes of an imaginative world. They thought they didn't. It turns out didn't have to actually give up on those imaginary those visions, but completely. But it wasn't the world they were hoping for. There weren't people to talk to there. But it certainly did. It did take the wind out of the people's sails and their imagination. So they had to imagine more far off places to go in other parts of the other solar systems, because clearly if Mars wasn't any good and Venus is already kind of not looking so
trashed, yeah,
it's looking a little too hot, too much pressure. But going out further, other solar systems and other places became the way of thinking about it. And of course, that was the same time that Star Trek was out, and they were using their imagination of going to other to stellar systems. And
that's true. That was the same year, wasn't it?
The same year, 1965, right? So, so Star Trek was a huge influence on how people thought about what space exploration might be, and particularly about how humanity might actually evolve in a positive way. It was kind of cool in that sense. But it was that Mars was a shock, and it really hit people hard. And I think, so someone looked for all the world like somebody took the moon and spray painted it red.
Yeah.
And that was it. Okay, we have a red version of our moon. In fact, the thing is now people started thinking that all the moons of all the other planets look the same. We're all just, they've already had that. We're convinced of that for Phobos and Deimos on Mars, but maybe all the Galilean satellites were also equally boring. And so it really actually took the wind out of the sails for not just Mars, but for interplanetary work altogether. Fortunately, we had missions already had the ball had started bouncing for Voyager even before Mariner 4 started. Of course, not the Grand Tour hadn't been invented yet, but the notion of getting money for going out the outer planets, the momentum had already been built for that. So Voyagers were already on their in some sense the momentum, because Voyager was actually the last Mariner series spacecraft. They don't talk about that, and it's actually much the same designs, just modified. Each Mariner spacecraft had new augmentations or additions or upgrades from the previous ones, but those Mariner 4 images really took the wind out of the sails for planetary exploration, period, to a large extent. If it wasn't for the momentum already built, it may have actually put the brakes on Voyager, for that matter.
So just to set the stage, Mariner 4 launched in 1965 after a failed launch by Mariner 3 a few weeks earlier. Mm-hmm. But up till that time...
Just a quick correction, it was in December, was it not? In 64? Because it took 6 months to get there?
Yes, sorry.
It did.
Okay.
Flew by in 1965. Thank you. Wait a minute. Slapping hand. Okay. But it was because I got all wound up in the bigger idea, which is, up till that point, Mars really became a target of telescopic study in the mid to late 1800s. And then here comes Percival Lowell with all his money to Arizona. I'm going to build a telescope to study Mars, and wrote a series of increasingly fanciful books. between the 1890s and early 1900s. By the time he was done, and if you read those books today, you can kind of see how he got there with what he knew at the time. But he had an advanced species of Martians that were building canals to duct water from the poles down to the arid equatorial regions to help grow crops. And they had televisions and teleporters and all kinds of stuff. Great reading, a little fanciful. But, that persisted well into the 20th century. And then in the, I think, late 40s, here comes Palomar, Mount Palomar Observatory. So we're getting pictures of Mars through this 200-inch telescope, but it's still looking through Earth's atmosphere. So you're still kind of seeing this wavering red blob. And you can, use spectroscopes and other things to get a little bit more science down off of the planet. But really, even when Mariner was flying, some of the maps we were using dated back 40, 50 years. And there wasn't a lot known. There was still talk, and correct me if I'm wrong, Rob, but there was still talk about the wave of darkening, which they thought might be plants growing and then dying off during the seasons. Still not quite certain about how much water there was in the atmosphere. Temperature was kind of better known. But there was still this possibility of, if not intellectually advanced life, at least more complex life forms. And the canal question hung over everything, which was a leftover from Giovanni Schiaparelli, who called the lines he saw on Mars canali, which we, of course, looked at and said, "Ooh, canali, that sounds like canals. That means intelligent people." So here's this classical Mars. And then, as I alluded to before, in this kind of one moment, Mariner 4 goes by. So if you don't mind, maybe you could just kind of walk us through how this began and what happened when they flew by.
Well, the big thing was, so Mariner 4 was actually a modified version. Same with Mariner 2 and 3, but they were modified versions of the Ranger spacecraft. If you remember, crashing relentlessly into the moon or missing the moon or something. It was a series. I forget what was it. Mariners. I'm getting I think it's Ranger. 6 of them. Yeah, the first 6
I think there were
failed.
9, but the first 6 failed.
6 failed.
Yeah.
There was a big space between 6 and 5. I think the first 5 died, and they said, "Okay, enough, JPL. You got to get your act together." So they went and stopped and refactored it. But what they pulled off one of the spacecraft. I think the first Mariner 2 was actually pulled off in the actual line. They took later on a version and modified it more further to create actually a Mars version of that. But if you look carefully, you'll see the structure and the architecture and the layout of the Ranger missions on the Mariner series spacecraft. They're all there. The control system, they looked many identical pieces of electronics, some of the structure. They had to add a lot of things like new solar panels. They put those vanes, weather vanes, on the ends of the solar panels. Steering vanes, yeah, to minimize a solar torque, impact of solar torque, so they can keep the attitude of the vehicle from being pushed out of the way. But they realized that they wouldn't they run out of fuel if they had to keep moving the spacecraft, pointing the antenna, keep the antenna pointed toward Earth, because of the pressure of the solar protons or photons had on the solar panels. So they had to do these little tricks to make that happen. So they had to do a lot of modifications, a lot of things, and their control systems were not good, so it was pretty darn exciting, because there was a lot of it, like many of our missions, a lot of things that were skin of your teeth, close calls. And I think you'd mentioned this in your article, Rod, is the Canopus tracker had. So what's interesting is that if you're one way to control your orientation in space is to have a sun sensor. The nice thing about the sun,
it's hard to miss, right?
It's hard to miss, and it's really bright, and so. There's a little sun sensor which basically measures the angle the sun, and like a bunch of fan detectors that can measure the sun in this axis, and another one identical, it's 90 degrees, that measures it this way. And from that, if you move the spacecraft so that the sun is kind of pointed along a particular point, now all you need to know is the roll, how much it's rolling. But to get the role, the orientation, you need to look at stars. And there's a really bright star in the southern hemisphere called Canopus. And if you know how far the mission is, you know where to point. If you had a little tiny telescope that had kind of like a sun sensor, except just focused on that one star, you point that thing at the right angle relative to the sun, and so as you go around the orientation of the sun, this Canopus tracker will bump into Canopus eventually. And so if you spin really slowly about the sun, eventually the detector will say, "Whoa, it's getting real bright. It's bright. Oh, it's getting dim again. Oh, go back. The vehicle will control itself that way." However, it's easy. Canopus isn't that bright. I mean, if you have like paint particles and other things floating around, our spacecraft, if you're not careful, they look a little bit like Pigpen from Charlie Brown, right? With all this little,
it kind of launched with its own little constellation of dust.
And remember how many times we had the Apollo astronauts go, there seems to be something following us. Oh, little bright little twinkly thingies. They're just, I don't know what those are. They're surrounding us. They're floating around. Well, they're just basically stuff that's kind of roughly in orbit around your vehicle, affected by the magnetic field and just basically trapped there. Or sometimes they'll wander off, but it's easy to. So that's what happened. So when some particles and stuff got in front of the field of view, and the thing actually locked onto those, and they're like, this doesn't appear to be Canopus. What happens? It disappeared. It seemed to wander off in the wrong direction. Canopus doesn't usually do that. And so it took a long time for them to keep hunting that down. But it was the same technology. Actually, Voyager has a Canopus tracker. I mean, it became part of the whole the toolkit. You just have to kind of realize it has these features of locking onto things that aren't stars.
I was really struck by the duality of Mariner 4. And the fact that they they launched Mariner 3 and Mariner 4 and Mariner 3 failed, and then Mariner 4 is based on an evolved Mars version of Mariner 2, which went to Venus, and Mariner 1 also failed to go to Venus, and so there's like a mirroring and an acceptance, I guess, of the challenge. We take Mars, maybe landing on Mars or getting to Mars for granted maybe now.
Well,
but
we shouldn't.
No one should. It's hard stuff. We couldn't do it.
It's hard to get it right. I mean, I have to admit, I am a personal fan of this idea of dual redundant missions, where you have two missions that they may have some slightly different science, where they cover different parts of the planet or look at different things. Spirit and Opportunity rovers, they're identical rovers. I tell you how convenient it was for me to be able to say, well, no, they're not single fault tolerant individually. And the whole bunch, thousands, if not millions of failures could happen on any one of those rovers, and they would die. But I have another rover there. It's on the other side of the planet, but who cares? It's on Mars. And so this ideal of dual missions, the duality you're talking about, is a real plus. It's a real plus because if one fails, you can go like, shoot, why did it fail? What went wrong? Can we figure out a way to avoid that on the other one? And it's interesting. You can. Oftentimes, if you know what happened, there's things you could do to kind of skirt that by how you operate it. And so, carefully, it's like hitting your head with a hammer. That's the way not to hurt yourself.
What a great thing to have the budget for two missions at once. And speaking of budgets, we have to support ours by running to a quick break. So we'll be right back. So this is one that's really gotten to me for years. I'm sorry, I have many passions about this mission just because I've written about it a lot, I guess. But when I was a kid, my father used to give music lessons. One of his students was a kid named Alan Leighton, and his father was Robert Leighton.
Yeah, Robert.
Who was on the Mariner 4 imaging team. He was an astronomer at Caltech. And so I got to hang out with him when I was a kid. Of course, at the time.
You're going to tell that story, right? Online? Alive?
Which one?
Are you going to tell the same story? Are we?
Which one?
Oh, the one you're telling right now.
Well, no, it's what got me about this was, he said originally, we weren't going to send a TV camera on Mariner 4. And I said, what?
Yeah.
So it was going to go out as Mariner 2 did to Venus. It was one of those, what your people call squiggly line missions where you get back this cool data, but not pictures. And Leighton, being an optical astronomer, said, well, this is an incredible opportunity to do more than any 10 big Earth telescopes could do. And in his opinion, we owed it to the taxpayer. So kind of, as I recall, late in the game, they started working very rapidly to add a TV camera. And at this point, a studio TV camera over at, TV City in downtown Los Angeles where CBS was or something, these cameras were about the size of a small dishwasher or a very large microwave. They were big. Yeah. They had lens turrets and all that kind of stuff.
Yeah.
And Vidicon tubes were kind of delicate glass vacuum tubes with a photosensitive pickup on the back. And I think they were in clusters for burgeoning color at that point.
No, just one.
Oh, was just one?
Yeah. Well, these are the first ones. Yeah. It's amazing.
But they had to figure out a way to, I think, oversee the manufacturing and testing of something in fairly short order for this mission, correct?
Yeah. No, this is, it is so funny because the arguments wasn't so much that people didn't want a camera, really. It was just that the squiggly, it's so much easier to build a mission with squiggly lines. Because the total data rate is so much less, and you can get it. You can take turns measuring different sampling different analog channels, like plasma wave and other things, and actually get it down and get it in real time. You didn't need any things like the trouble with a camera. Even with a fairly slow exposure on a Vidicon tube, and the Vidicon tubes are only about this big, right? They're really small. They have a screen. It's a screen. People don't realize it's actually a television tube, just like just like the TVs that we had as kids. Little TV tube that kind of worked backwards. Whereas a TV, the electron beam would go through and then basically scan back and forth, and was brighter. Where it was stronger beam where the pixel needed bright. So there's phosphors painted, little dots painted on the screen. In fact, there are 3 colors of dots, and if you carefully aim it, you can pick which color the beam is aiming for, and you can do that. Scan, and that's how, and they do it fast enough their eyes don't notice it, and it looks like a real moving picture. And now, what's cool about a Vidicon tube is it's basically the same thing in reverse. Basically, you project an image on the end of your video tube. And then you have another, exactly like the same, the electron beam scanning it, but this time the electron beam is sensitive to the brightness of the light that's on the screen, and the amount of current in that beam drops if there's not much light. If there's a lot of light, it gets stronger. And if you just measure that and send it down, you get a squiggly line, just like other squiggly lines where you measure things. But then you have to do it for that line, then that line, then that line, and you have to go all the way down. Oh, by the way, only one color. Color. And to get the other colors, you have to do this all over again with a different color lens, color we put it between the lens and the light. So basically, in front of the lens, I think. And so it's basically blocks all the other colors except for red. And so red goes on there. Then you have to take 3 colors, 3 different pictures to get a single.
Right. So, but Mariner was just black and white.
Right, black and white. So they only had one. They didn't have a color wheel. Right. We call it a color wheel, but that's how they got colored later on, like on Voyager. But the trip was that's a lot of data compared to just I'm listening to the plasma wave, up and down it goes. So this is like so just a huge amount of stuff. And you can't get it down to Earth that fast. So you have to put it someplace. So you need a tape recorder to shove this stuff in. And then you need a mechanism to play the tape recorder, usually backwards and reverse. You don't actually go back and rewind and play it again. You go back, you play the whole thing backwards. It comes out the other way, and then it goes into a tape recorder on Earth. It's a huge amount of data. It's a huge amount, and it overshadows the squiggly line data that the other scientists wanted. So the other scientists are worried that they're going to lose their data if you put a TV camera. Put one of these little Vidicon tubes in there, they're not going to be able to get their data because the TV is such a hog. And it's a hog in other respects, not just data. It's also a hog in money because you have to have this complexity of this extra tape recorder. You need complexity of of getting the data down, and it's going to threaten the viability of the mission itself. So they're like, man, tape recorder, television. No, oh, and by the way, they're going to take all my mass because they're going to grow in mass. It's going to go it's going to be something small, and it's going to grow from a microwave oven to a refrigerator, just like you said. I mean, because they hadn't really mastered the art of making these things reliable because they're so dinky. They're really small, and you have to get it focused nicely. So, and that was so there was a lot of risk, and there's a lot of development. So there were people at JPL who became really good at designing, or at least monitoring the companies who are good at designing these vacuum tubes, designed specially for these applications. Everything was very bespoke, all designed by hand, because in those days we didn't have computers to help us design stuff.
But you had slide rules.
Speaking
Slide
of
rules.
by hand, there was that first TV image from Mariner 4 of Mars. You know,
Yeah.
I think, dear listeners, you heard Rod and Rob talking about how this camera was black and white, but there is a color image that I actually met when I was as a little college, cub reporter when I was visiting JPL's press. Press corps. They were walking me through like how they did everything, how they shared images with the public, and they took me into the back room where the image specialist, and I can't remember his name. Rod, you'd probably know him, but Yuri.
Yuri?
Yuri.
Yuri Van der Wert. Yeah.
Van der Wert.
He's like, this is the room. This is where we got the big thing, and we hand colored the picture of Mars.
That's right.
Yeah.
Oh,
And
wow.
it's we've got it, John. We've got it on line 46 there, if for folks that are watching there. But that's on display at JPL.
Yes,
You can
it
still
is.
see it there.
It is. It was in color only because they picked color range of a spectrum of pastel colors, right?
Yeah, they colored
It was
for
such
black and white.
a cool story. I mean, so just again for context, this there's a paper printout of this first digital image. It's 200 pixel, right? Digital image of Mars.
Well, do you remember those old like line printers that go tunk? It went and they had to dig scissors, and they had to, because their spaces were so big, they had to just cut them out, and each one had a octal number that would represent the brightness of that pixel, and they had to line it up, and they lined it up vertically across, and they took their colored pens or colored pastels and colored each pixel based on the numbers. So it's like paint by numbers. Exactly the same thing.
And I don't know if this is apocryphal or not, but I did read one account that said that a couple of, because this is NASA and JPL in their ad hoc days, right? So a couple of guys said, "Oh, I got an idea," and drove down to Pasadena Art Supply, which was open for many decades, since closed, and said, "We need some grease pencils, some pastels." They said, "Okay," and they said, "We got orange and yellow or green and brown," and they were like. According to them, there was a toss-up moment in their thinking. It would have been a really different experience if it had been green and brown. I don't know why they'd pick green and brown, or maybe it was they only had green and brown, then had to go back to find the orange and yellow or something. There was some hang up there. But when I first went into the comms building and saw that thing hanging there and realized what it was like this holy relic moment for me.
Yeah.
Because it was such a cool thing that they did. And then the actual image finally gets printed out and dried and hung up. And it was really close, except that it was black and white and this was in color.
And a little stretched out this way, yeah. They had to cut them a little bit closer together. But you're absolutely right. You may ask the question, well, why did they do that? So remember now, these images, they come down two ways. They come in. They were coming into the tape recorder first, and then they over the next hours, like 6 or 7 hours, a good chunk of a day, right, Rod? You know the numbers. I forget. Yeah. And it comes, and they play it back. Then it takes a fair amount of time to process that because we didn't have a bunch of computers back then to help us. And so, but the data was there, and the imaging team just printed it out on their teletype, the line printer, ka-tunk, and so they said, we don't have to wait, we can just do it now. What? And you just need a bunch of this, a gradation of color, of a single color. It doesn't have to be blue, green, whatever they pick, brown, I guess, orange. But the funny thing is when they finished that, and I'm sure Yuri mentioned that, right? That they said, look what we did. don't show anybody. We don't know if that's right. I mean, part of it, they didn't know what they're looking at. For example, that bottom part of that image, is it possible you pop it back up again?
The big white blob?
Well, all the black stuff down below.
Oh, yeah.
That's black space. So that's the limb of Mars.
Oh.
And so if you, to the middle, the lower part of that black part, the dark brown actually in this picture, but it's actually black. The lower left-hand quadrant, you can sort of see lines in the black, or the brown in this case.
Cows.
And that's the atmosphere. That's the you can sort of see. So what you're looking at is, if you turn it upside down, you can see you're looking out over the curvature of Mars. And
Oh, yeah.
I don't
layer
know
of
that. Okay.
Yeah. So it's so, but they didn't know that. They didn't know what they were looking at.
Well, and to be fair to the squiggly line scientists, just to cap off your TV camera story, I think each image took 8 hours to send down, and they had to do it twice. So now that you contextualize it this way, I have to lighten up on they wanted to send it without a TV camera, because it actually probably made a lot of sense to those guys.
Well, it made sense because the price is right too, right? Because adding a television is a huge step up in complexity. And it wasn't just the ground software. It was, this whole, how do you get a tube that doesn't shatter itself during launch? The launch vibrations,
all the phosphors off the back.
Yeah. I mean, making things that can survive a launch vibration. You don't put glass out there. God, are you kidding me? Why would you put? Why'd you put little? Yeah. So you had to be very good at holding it, stiffening it up, making sure it doesn't vibrate, and all the issues associated with the contaminants and everything else that associated with making a tube that doesn't leak. I mean, it's really hard to make a tube, by the way. That's why in the old days, remember the old, we're talking to old people. We used to have stereos with all these tubes in it, but the typical lifetime of a stereo amplifier with all those glass tubes, vacuum tubes, was about a year or two before you lost one of those tubes, and you had to go find another one, and they all burned out on you. Kind of like the old light bulbs, except worse.
And something Tariq has never seen is the tube testing console at the grocery store, where you'd take your vacuum tube out of your stereo or your television set, and you'd go look at a little book, and you'd fit it in the right plug, and it would test it, and then it would sell you another one. But speaking, I
had a stereo with tubes. I think it. My mom gave me her stereo, and it had tubes.
Yeah, you nerd.
Very, very
okay,
nice.
Well,
a nice hum when it warmed up. So.
All right. I know you have many questions, and we've been ignoring you, so we'll be right back from this next break. That was how I was getting the segue to listen to Little Tariq. So stand by.
I don't know whether to feel thankful or feel patronized, Rod. All right, I'm just saying is that I had a stereo with a turntable and everything that had tubes is all.
And people still seek those out. That's a head scratcher for me. I've got a tube amp in storage somewhere. Rob, is it because the sound is warmer or something?
Taste. It's whatever you like to hear. I mean, I think in some sense they do have different roll-off properties, so there is slightly different sounds. So, but it's a matter of what you like. We've lived in our digital world for so long. We know how to render things with incredible precision. But in some sense, these tubes actually alter the sound in ways that people enjoy. And it's not.
We should get the sounds of Mars through those tubes. That'd be awesome. So.
Hey, Tariq, when you ask your next question, we also got one from Wizardling on Discord. What were the highest and lowest tech parts of the Mariner mission? So we'll get to that after your
That's actually good. We talked a lot about the TV camera, and I'm very curious about everything else that we learned from Mars, from Mariner 4, because this is where, we've been, people might have missed it. It's a flyby. It's not, you didn't go into orbit, right? With Mariner 4. This was like a zoom. You take all your pictures, and then, that's it. Mom's not going to pull over so that we can get out and take a picture of the dinosaur. So, like the roadside dinosaurs, like in California? We used to drive by those all the time.
The cement dinosaurs, yeah.
Yeah. And so this is like that first close-up look, Rob. What there's like a occultation experiment that we mentioned. Yeah. There's a few others. Like it's what did we learn? Well, that was the first of all of this stuff. So,
well, I think the big ones. First of all, realizing there are certainly no canals on Mars and no trees, no cities, but also this kind of shock that, and Rod, you mentioned this, is the discovery that that Mars' atmosphere is a lot thinner than they thought.
Mm-hmm.
Yeah, so Werner von Braun's idea of landing a dozen or so astronauts on a glider on unprepared surface on skids may not have been the safest thing to do. You know, I calculate that if you were to land on the actual Mars atmosphere with a large glider, uh, uh, you'd be going very close to 1,000 miles an hour
Oh my God.
on skids, unprepared surfaces. What
On
are
a
the
rough
odds?
ice, yeah.
On right, can you imagine? There's nothing. It would be a bad day. It'd be a bad day. And I think we learned that Mars is going to be more challenging than they thought in terms of how to get to the surface of Mars, because you don't land on Mars like you do. They're hoping to be able to land on Mars, but an extension of how we do it on Earth. Maybe not with parachutes, but certainly with wings or something. But even parachutes won't do the job by themselves without something else.
And you've landed on Mars 5 times by my count, right?
Not me personally. I have never been there.
You know what I
But
mean.
yes, I do. I'm joking. Yeah, I've been there virtually with my robotic friends, and it is a real pain. But that's what's sort of the discovery. Like, oh crikey, it's going to be really hard to land on Mars in the future. So it really kind of changed and it really changed the modality from a lot of different perspectives, because it looked like with much less atmosphere, there's less likely that to have a more dynamic place. Like, where would the water be? How could you have had water if there's no atmosphere there? It's only 1% the density of Earth. Maybe Mars was never wet. And it wasn't until we got later images from first Mariner 9 and Viking orbiters that we realized that Mars had been altered by vast amounts of water flowing on its surface, which kind of changed this dynamic even more. Again, like pump, flip, flop, and so but that was years later, half a decade, no, a decade later. So it was. I think those are the two biggies that we learned. I mean, and of course, from a technology perspective, it was modeled a lot after Mariner 2 in terms of the technologies for guiding your vehicles. One of the challenges for getting your spacecraft across is knowing where your spacecraft is.
Yeah.
There are actually two issues: knowing where the planet is, and knowing where the spacecraft is.
Yeah.
So how do you figure out where your planet is? Well, you take pictures of from Earth, right, with a camera and a mount. And a telescope on Palomar, you center it in your screen. So what direction is that? In absolute as L elevation at that point, at that long latitude and longitude and that date. What is that? Oh, well, it's roughly that. It's kind of fuzzy. How is the gimbal? Is the gimbal calibrated properly? Well, normally we don't actually try to get the accuracy from that thing. We just look at relative to other stars. Oh, crikey. I mean, so it was like, it's really, there's a fuzziness in your understanding of the direction to Mars, and even larger fuzziness in terms of a ruler, in terms of how far Mars is away from you. You have to rely on models such as Professor Kepler, Johannes Kepler, who gave us the equations for orbital dynamics, orbital space shapes, and we could use those to help estimate where the things are. But it's going to be off by many, many kilometers, many kilometers. And so, so they had to aim a good distance away. If there's two reasons out of focus, the focus were not that great. One is it was actually taken from a good distance away. They didn't want to get too close to the darn planet and bump into it. So they kind of erred to be on one side of Mars. The trouble with that is, how do you know where to point the camera? And when to point the camera, when to go click. That's also a real challenge because it's not just because you're moving by so quickly. If you go click with it, and you've got a Cassegrainian telescope that we put this in front of this Vidicon television. By the way, use the word television. They called it television in those days. It's a television image, not a television motion picture. It doesn't move. So just a click, we're done. Put it in the tape. Put it in the tape recorder. Keep recording it. So it's really challenging to get your vehicle to do all those things, to do the motions, to click, and the telescope is you're far away. If you were on the vehicle looking at Mars that was going by, it's not that this planet going whoa right past you. It's more like this this dot going this this quarter going by in front of you, and you're trying to like click. Maybe it's a little bigger than a quarter, but it's not very big. It's pretty small. It's pretty small in front of you. So it was a tough challenge, and those kinds of things were really pushing the envelope of getting the measurements right and doing the right metrology, measuring angles of the vehicle, knowing where things are. The one good thing is, as they approached Mars, they did something like they started doing some Venus too. You get a better understanding where Venus was relative to your vehicle by you taking pictures of the vehicle, and you take the pictures in a direction that you think, because Copus is up there, the sun's over there. Okay, I'm going to take this picture in this direction. Click. Where is Mars in the frame of the picture I took? And from that, you can figure out, if you know how the camera is pointed on the vehicle very precisely, you can count the number of pixels where you put it, where the picture touch, where the center of Mars showed up. You can sort of estimate. In fact, you can estimate even less than a pixel because it's a blur. You can estimate. We call something called a point spread function to see how the blur is kind of spread out. You can estimate where the center of that blur is. Even it's inside of a pixel, to try to make a better job of doing angles. So there are people whose job it is to do this incredible checking and double checking of all these very tiny double measurements.
That's a lot of math. That's a lot of math.
Tariq, is your head hurting like mine yet?
Yeah.
So just to clarify, Tariq, and then I'll let you get back to your question. This is not a real time, we got a picture back, we're pointing in the right direction, or we're not, let's make an adjustment. This is you have to have all this figured out before the flyby, or you're going to be taking pictures of empty space instead of your target.
Well, that's right. And that's kind of, it's easy to do. I mean, in the case of Mariner, one of our Ranger spacecraft, we were supposed to take pictures on the way to moon. It took all its pictures before it got to the moon.
Oh, no.
Inside the fairing on the way up to outer space.
Oh.
Click. Oh, I got pictures of the moon.
But this is the problems that the Soviet Union had, where they'd pre-program their spacecraft and then they couldn't reprogram them.
Yes.
Like when Mariner 9 arrived and there was a dust storm on Mars, and the Russians, blew their wad shooting pictures of dust.
Dust. Yeah, no, that's true. And the thing is, you might say, well, that's silly. Why wouldn't they program? Well, it turns out Kepler's laws say you should be there in roughly the right spot. So you can program, when things are going to happen. Nice thing about Kepler's laws and position in orbit, you can predict where things are going to be with some pretty remarkable precision in the future if you know what the thrusters are doing and there's no one pushing your spacecraft around. So that's what the Russians were counting on. And there's a lot of complexity by having it pre-programmable, and in those days, because we didn't have very complicated computers. All the computers that we put on our spacecraft in those days were very simple things. They couldn't even do computing. They couldn't do arithmetic. So simple, all handmade, bespoke, specifically for the mission. And so it was, again, everything's wired by hand, designed by hand, by individuals. Then we had huge amounts of technicians at JPL doing. So we had more technicians doing things like wiring and checking solder joints and making sure all the wires went to the right spot, and all hand assembled. Even the circuit boards were hand laid out. Mm-hmm. They didn't have computers to do that either. So in many cases, we didn't have circuit boards. We just had wires. The wires would come out to a little stub, and they would take a little solder a wire from here to here, and then glue it down, and glue it down the back of the board. So it's just a bundle of wires down there that any one of which could break. So that's one of the things we started doing, is putting a little bit of redundancy. There wasn't a lot of redundancy on Mariner 4, but there was some. Mm-hmm. But it was easy to break.
That's great. And I guess really quickly, I would probably want to run down. There was like a magnetometer to study the magnetic field.
Oh yes,
there was
that's true.
A dust detector for the dust environment, a radiation detector, right? And a solar plasma probe. So a lot of different things. That they got for the first. So
and discovery that there's not much of a magnetic field on Mars is a pretty big deal. Yeah. So that tells a lot. And by the way, what's so cool is that we're JPL, and was really because Ranger was going on at the same time as the Mariner program. The JPL the people were just learning this on the fly, mm-hmm. and we had at the time the leader for Mariner 4 was a fellow by the name of John Cassani, who a couple of weeks ago passed away, sadly, at the age of 90 92, 93, something like that. A legend
Still
at JPL.
working.
Yeah, he was still working. Yes, I was working with him as recently as last summer. And he'd started in, I think, 56, I think 1956, as a young engineer. And he was the manager for for Mariner 4, and to make that happen, to make those decisions. So he's the one that struggled to get this camera put on, and he agreed. He's the one that had to agree that we're going to put that on there. But he became a fan of cameras ever since. He's been huge influence on all of us in terms of being among the inventor. How you do this stuff? How do you build these things? How do you test them? How do you you can't? Can you test your spacecraft on Earth? How can you test it by being able to turn around? They actually tried testing those things, testing our thrusters to see whether it would work and get enough. And in our big thermal vacuum chamber, that didn't work out. So they just realized that some things you just can't test. You just have to do the best you can and build it up. And so it was a lot of things like that. How much margin you put in your design, what the temperature ranges, things need to be checked out to make sure they work, because some parts of the vehicle are really hot, other parts are really cold. It was a free for all really to figure this out, and the kinds of things we need to do that they were just basically inventing at the time. Mm-hmm. And that we've all benefited from those experiences that those people had. And John was the leader, technical leader for those. And he was a big inspiration because he was project manager for Galileo, for Cassini, for many other missions, and an advisor to me. Spirit and Opportunity wouldn't have ever happened if it wasn't for John, it turned out. I'll tell that story some other day.
And you know him 1,000 times better than I do, but I had the chance to interview him for quite a number of hours. And one of the things that always struck me is he wasn't shy about expressing himself.
Really?
And
John?
He wasn't shy about speaking truth to power. And when I was in your archives, going through various memos back and forth from the Mariner and the Viking era for this Mars book I was doing, I asked for a bunch of boxes of John Cassani memos. And so they rolled them out, and they all had like red tape along the side. And I said, what's that for? She said, oh, these are restricted. I said, why? What? And she said, oh, you'll see. So I, had my white gloves on. I opened them up. And he used some very compelling language to get NASA to come in line to support what you guys were doing. I mean, he was a real fighter for the lab, and he wasn't afraid to put apparently, from what I saw, again, you know him better, didn't seem to be afraid to jeopardize his career standing to say, look, this is what we have to do to make this work. And if you don't, it's going to fall apart. So get with it. Yeah. And I think sometimes, as Tariq and I, and I'm sure you kind of watch the machinations going on in Washington and at headquarters, I hope there's somebody there doing that now, because I think. Right.
I don't know. We definitely needed people like that to speak truth to power and to do it with unabashedly and totally fearlessly. And that was John all the way. He was. I don't know. He's either self-confident or I don't know what he was, but he was definitely one of these people that, this is my opinion. Get over it. I mean, I'm looking at who he put this golden record. It was him that he worked with
Carl Sagan.
Carl Sagan and his wife to what's her name? Having a mental blank.
Anne,
yeah, and she who actually muscled a lot of this stuff into reality was her energy behind it. But she John let that happen, and he just not just let it happen. He was encouraging it. He encouraged us to go ahead and put cameras like on our vehicle on Perseverance, making those movies about EDL. He was a huge supporter of the Mars helicopter. And just trying to pushing the state of the art, becoming innovative. Taking risks at the right time in the right place. He was not afraid, and that really I think really inspired me and many other people at JPL to realize that, this is a very scary business. I mean, it's nerve-wracking. It's nerve-wracking to be on national television responsible for billions of dollars of taxpayers' money and trying to land on another planet. You got to imagine it's very stressful when everyone's looking at you and expecting the worst. But you got to be. There's a part of you that just has to be like, "Que sera, sera." I'm going to do the best I can.
Well,
if it's not good enough, not good enough.
Which mission was it where you had the NASA administrator and I think it was the vice president of the United States standing in the control room, right? While you're trying to get this thing on the ground?
Yeah, it was Spirit and Opportunity.
Spirit.
It was Spirit, Spirit and Opportunity. We did have the national administrator. We had Dan Golden in the room for Pathfinder landing, though I think he was hiding with Tony Spear, the project manager, in the back room, in total fear. No, he wasn't. But they were very nervous, and rightly so. I mean, they're out of control. It's not their control, but it's you have to be a little bit
Nerves of steel.
No, it's not. No? You have to be properly paranoid, as Gentry Lee likes to say. Properly paranoid, and being afraid at the right level, and being wise about that. But once you made your decision and you've tested and you've done the best you can, keep pushing. Make sure you're at the top of the mountain, because that's the hard part, is knowing when you're done. Because you don't often know when you're done. You don't know if there's something more out there that you didn't find. And when we're seeing that with some of these missions that are not working, that don't land well on the moon, for example, these are people who've never done it before, who are struggling, and they're just realized they don't know how to get to the top of the mountain. They've never been up there. They don't know that this little valley that they're on is actually not the top. There's more ahead. So
yeah, there seems to be and I don't want to get off on another tangent because we're running out of time, but there does seem to be in the private sector a little hint of how hard can it be? We'll show those NASA guys. It's easy. It's cheap. Oh, wait, no, it's not. Oh, I guess they knew something after all. Well, am I manufacturing this, or is there?
Well, I think I think it's a little of that, but I think it's mostly hope it can be a great strategy. It's a great motivator. And I especially since I've been guilty of that. Mars Pathfinder we did on a fraction of just a tiny fraction of the cost of the Viking landers. We did this 20 years later, and with the purpose to do a fixed price, low budget mission about the cost of a major motion picture in a fixed price environment, and to land on Mars and deliver a little rover and drive around and do a little bit of science and just prove to the world that we can actually go there again after a 20-year hiatus. But to do that, we needed, sorry, my note, to do that, we needed to have we need to be able to I'm sorry. I mean, my sound's not working very well, but we need to be able to be a little arrogant and a little bit stupid. And that really does help to a certain extent. And you could be, the nice thing about it, you can also be innovative. You can try out things that no one else would dare to do because you don't know that you're being daring in the first place. And so that's the kind of environment that we grew up with in Pathfinder. But over time, it's harder to make that happen because of the cost and complexity and the visibility that people are looking over your shoulder and saying, questioning your every move. Rightly so, because we're talking a lot of money, and it's not our money; it's your money. And
that's true, but as I recall from speaking to you years ago during another book project, the lack of, and not oversight, the lack of scrutiny from the big masters on Pathfinder may have helped keep it inexpensive and rolling along.
It did. It was we basically, because we didn't have any. I mean, the first major review of the details of inter-descent landing was done 5 days before we landed.
Well,
and these guys are like looking, they're like white as sheets, and it's like expecting it to fail. By the way,
why didn't you tell us this before? Yeah,
I know. It's like, yeah. Well, so I went through explained all the details of inter-descent landing and all the testing we did, and they looked at me as like, so you think this is going to work? They thought maybe it was just, I said, well, I can't say for sure, but we did everything we thought we could do, and we finished on schedule. We finished our testing.
You were in your mid-40s then? That would have been like 96?
Yeah. Yes. I got to around 40. Yeah.
That's
Yeah.
that's gutsy. So
Yeah.
my last question for you is: you are Rob Manning, Chief Engineer Emeritus. What does the Chief Engineer Emeritus do in his next act?
My next stack is just to help out next generation as much as I can, and so to try to get the next group of people to feel confident, brave, to learn from the past, understand our patterns, but don't fall prey to heritage or history. Be innovative, but do your best to understand why we are the way we are, what happened, and how things work. Figure it all out. Then go out and go off road. Do what you need to do to make it work.
Wow, that's cool. That's a cool statement. Tariq, you got anything else?
No, I mean, that's great. That's great. Dare mighty things, right? Got us to Mars over and over. Let's go back again, right?
I've heard that phrase a few times. All right. Well, I want to thank everybody, especially Rob Manning, for joining us today for episode number 169 that we like to call The Day Mars Died. Sorry, that's a little bit of a downer, but it's got drama to it. Other than the various pages on the web for JPL and NASA at large, where can we keep track of what you're up to, Rob?
I would stick with the JPL pages.
I think there's still
changing all the time.
Your original Mars Pathfinder site is still up with you with the dark beard like I had in the days and all that.
Yes,
and it's cool because it's optimized for Netscape. Tariq?
Well, you can find me on at space.com as always, on the Twitter or X, pardon me, and Blue Sky at Tariq J. Malik. And if you like video games, and I can hear Rod's eyes rolling out the back of his head, you can find me on YouTube at Spacetron Plays. I got a great video there about crypto and space dogs, like real life space dogs. So, and crypto came first. I was very surprised.
Okay, got it. And I didn't get to finish my lead into. I was going to say, Tariq, where can we see you grabbing my suborbital flights online? You missed that part.
Shout out to Steven, by the way, who followed us on the podcast and then followed me on the YouTube. That's great. Thank you, Steven.
One fan at a time. Rob, we're still getting requests for questions to ask you. We're going to have to roll them over to next time. But
okay.
Clearly, you are a beloved storyteller. And of course, you can find me at pilebooks.com or at astromagazine.com, my two increasingly aged websites. However, we just did get a shot of money to revamp the Ad Astra Magazine site, so stay tuned. Remember, you can drop us a line at twis@twit.tv. That's TWIS at twit.tv. We welcome your comments, suggestions, and ideas, and one of us will answer them, probably me, within a day of receiving them. New episodes of this podcast published every Friday on your favorite podcatcher, so make sure to subscribe, tell your friends, give us reviews, and all that kind of stuff, because we love you and you need us to leave us. And love us. And don't forget, we're counting on you to join Club Twit in 2025. It's only $10 a month. What else can you get for $10 a month that is as much fun as this was today? Helps keeps us on the air and bringing you all this great goodness. $10 a month. Sign up now. Rob, thank you very much.
You're welcome. It's my pleasure. Thank you so much for inviting me. Anytime, you guys.
And behind the scenes, John Ashley doing a fine job between yawns. And love, peace, and Bobby Sherman to everybody. We'll see you next time.
No matter how much spare time you have, twit.tv has the perfect tech news format for your schedule. Stay up to date with everything happening in tech and get tech news your way with twit.tv. Start your week with This Week in Tech for an in-depth, comprehensive dive into the top stories every week. And for a midweek boost, Tech News Weekly brings you concise, quick updates with the journalists breaking the news. Whether you need just the nuts and bolts or want the full analysis, stay informed with twit.tv's perfect pairing of tech news programs.